Ever look at an app on your phone and just wonder how it got there? I mean, how does something go from just an idea to this thing you use every day? Well, it's definitely not magic. It's actually a really structured, engineered process. So today, let's pull back the curtain and see exactly how software gets built.
No, really think about it. That banking app, that game you can't put down, it all started with a blueprint, a plan. And we're going to dig into the different kinds of blueprints engineers use to build the entire digital world that's all around us.
Okay, so first things first. Before we talk about building software, we've got to be on the same page about what it even is. And most people think it's just the code, but it's so much more than that. Real professional software is the whole package. You've got the program itself, sure, but also all the documentation, the manuals that explain how it works, and the procedures for how to operate it.
So if software is this whole complex thing, how in the world do you manage it without it turning into a total mess? That right there is where software engineering comes in. See, this isn't about just winging it and hacking some code together. It's a real discipline. It's about bringing order to chaos, making sure the final product is reliable, maintainable, and, actually does what it's supposed to do.
So let's jump in our time machine and go back to the beginning. One of the very first big ideas for bringing order to software development was a method called the Waterfall model. And the name really says it all. Everything flows in just one direction, straight down.
Here's the play-by-play. You start at the top by gathering all the requirements from the client, every single one. Once those are set in stone, you move to the next phase, design. Then, and only then, do you move to implementation, which is writing the code. Then you test it, then you deploy it. The key rule here is you have to finish one phase completely before you can start the next. There's no swimming back up the waterfall. It's super strict.
And that rigid step-by-step nature is both its biggest strength and its biggest weakness. Look, if you're building something small and you know exactly what's needed, it's actually great. It's simple, it's easy to manage. But here's the massive problem. What if there's a mistake in those initial requirements? You might not find it until you're way down at the testing phase, months later, and fixing it then is incredibly expensive. Plus, the customer doesn't see a single thing until the entire project is done.
That major flaw in the waterfall model, that total inflexibility, was a huge issue. So naturally, a new way of thinking started to bubble up. People started asking, hey, what if we didn't have to build the whole thing all at once? And this led to a whole new class of approaches called evolutionary models, which are all about building software one piece at a time.
Let's use that banking app again. With the waterfall model, you'd wait a year to get the whole thing. But with an incremental model, you'd get it in chunks. Increment 1 might just be a working app where you can log in and check your balance. That's it, but it works. Then the next increment adds fund transfers. Then another one adds bill payments. You see? You get a usable product in the customer's hands way faster.
Now, that incremental model is part of this bigger family of evolutionary models. And the core idea behind all of them is really simple, but it's also incredibly powerful. Build a little bit, get some feedback, refine it, and then repeat that cycle. It's a continuous loop that's designed to deal with the reality that, let's be honest, we almost never know everything we need right at the very start of a project.
And within this evolutionary approach, there are a couple of key strategies. First, you've got the prototyping model. Its main goal is to figure out, is this what you actually want? It does that by building a really quick, early version, like a mock-up, just to get user feedback. Then you have the spiral model. This one is for the big, high-stakes, high-risk projects. Its main goal is to systematically find and destroy risks in every single cycle of development.
Here's a perfect real-world example of a prototyping. Say a bank wants a brand new ATM interface. Instead of just guessing and building the whole thing, they create a simple software simulation of the screens. Then they can put it in front of actual customers and ask, hey, does this make sense? Can you figure this out? Getting that feedback early on saves a ton of time and money, and it stops them from building something that people hate to use.
And for the spiral model, well, just think NASA. When you are writing software for the space shuttle, failure is literally not an option. So for them, each spiral or loop in their process involved just intense risk analysis. What could possibly go wrong with a navigation system? What about life support? They would identify every risk they could imagine and then build the next piece of the software specifically to eliminate those risks.
But even with these improvements, the world just kept getting faster. Project requirements started changing all the time, sometimes week to week. This chaos demanded more than just a new process. It needed a complete change in mindset, and that's what sparked the Agile revolution. Now, Agile isn't just another model you can pick from a list. It's a philosophy. It's a mindset that fully accepts that change is going to happen, and it says that responding to that change is more important than blindly following some master plan. The absolute key here is collaboration, bringing everybody, from the engineers to the customer, together to deliver value quickly and constantly.
The most popular way to actually do Agile is a framework called Scrum, and it works with a small, focused team that has 3 very specific roles. First, you have the product owner. They're the voice of the customer, and they decide what gets built. Then you have the development team. They're the builders, the ones who figure out how to build it. And finally, you have the Scrum Master. Think of them as the coach, the one who clears roadblocks and helps the team perform at their best.
So, work in Scrum happens in these short cycles called sprints, usually about 2 to 4 weeks long. At the start, the team plans what they can get done. Then they get to work. And to make sure everyone's on the same page, they have a quick 15-minute check-in meeting every single day. At the end of the sprint, they show off the actual working software they built. And then they huddle up to talk about what went well and how they can get even better for the next sprint. It's this tight, disciplined loop of constant improvement.
Whew! Okay, so we've got Waterfall, we've got the evolutionary models, and we have Agile. So, which one's the best? Well, that's actually the wrong question to ask. The real key is knowing how to choose the right tool for the right job. So let's break it down really quick. If you're working on a short, simple project and the requirements are absolutely locked in, believe it or not, Waterfall can still be a good choice. If you need to get core features out the door super fast, like for a new website, the incremental model is your friend. For those huge, complex, mission-critical projects where failure is just not an option, think NASA, you need the risk-focused power of the spiral model. And for pretty much everything else in our fast-changing world, Agile and Scrum are the go-to choice.
So, from the rigid, straight lines of Waterfall to the fast, flexible cycles of Agile, the way we create software has constantly changed to meet new challenges. And that really leaves us with one big question to think about. As technology just keeps getting more and more complex, what new problems are we going to face, and what will the next revolutionary model for building software even look like?